Hello students, we are studying about phenols. So in that classification of phenol, then nomenclature of phenols, how to prepare phenols and manufacture of phenol also over. Then in acidity of phenols, we are studying regarding what phenol acidity based on EDZ, electron donating group, and electron withdrawing groups. But phenol is said to be acidic, not an acid. Phenol is acidic, not an acid. Because phenol dissociate to give hydrogen ion and phenoxide ion. The acidity of phenol mainly due to stability of phenoxide ion. Stability of phenoxide ion. There is a phenoxide ion is more resonance stabilized than what? Phenol. See here, phenol undergoes ionization to form phenoxide ion and hydrogen ion. Phenol dissociate to give phenoxide ion and hydrogen ion. If stability of the product ion is more than reactant, then forward reaction is favored. Therefore, because of higher stability of phenoxide ion, phenol is said to be what? Acidic in nature. Means the main point regarding acidic nature of phenol is this one, stability of phenoxide ion. Next, if EDZ groups present, EDZ and EWZ, electron donating group, electron withdrawing group. Electron donating groups: methyl, ethyl, alkoxy, ether group, alkoxy, amine group, and secondary amines. Yes, these groups are said to be electron donating groups. And electron withdrawing groups: NO2, CN, CO, X, fluorine, chlorine, bromine, iodine. Here aldehyde ketone, CO, CHO, and even COO. Next, cyanides or nitriles, nitro compounds, or nitro group. So these group, if they are present on the benzene ring of phenol, then I told yesterday in last period they increase the acidity. Electron withdrawing groups increase the acidity of phenol, whereas electron donating groups decrease the acidity of phenol. Okay, what is the effect of methyl group on acidity of phenol? So answer is it decreases the acidity of phenol. Then you have to say reason. So why it decrease the acidity and why such groups, NO2 groups or NO2, CN, etc., they increase the acidity. But about this yesterday I explained. Which one? If NO2 group present on the ring of that phenol and they withdraw electron from the ring, means they are electron withdrawing groups, and electron density on oxygen decreases, and OH bond is more polar and dissociation is more, and giving higher concentration of hydrogen ions. That's why nitrophenols, maybe ortho nitro, meta nitro, para nitrophenols, all these are said to be what? More acidic than phenol, or they are stronger than phenol. Even if you study pKa values or Ka values, right? If pKa value less, acidic strength is more. Ka value is less, acidic strength is less. But Ka value and strength of the acid directly proportional. pKa value and strength of acid inversely proportional. Correct? Yesterday I told about nitro group, effect of NO2 group. NO2 group increase the acidity of phenol because it stabilizes the phenoxide ion. Stability of nitrophenoxide ion is greater than phenoxide ion. That's why nitrophenols are said to be more acidic. Next, I will explain what is the effect of methyl group. Effect of methyl group or electron donating group. Now see here, what happens when methyl group is present or electron donating group is present. Methyl group is said to be electron donating group, and here electron pairs are moving towards benzene ring, but through sigma bond, means inductive effect, through inductive effect, yes, it opposes incoming electrons, and electron density on O increase. Therefore, OH bond what less polar, OH bond less polar, or strength of the bond is more and ionization is less, therefore giving lower concentration of hydrogen ions. Therefore, it is called less acidic than what phenol, In other words, we can write like this: negative charge on the oxygen delocalized with benzene ring, but methyl group, EDZ group, it opposes what resonance. That's why methyl phenoxide ion, it is said to be less resonance stabilized compared to phenoxide ion. Therefore, methyl phenol or cresol is said to be what? Less acidic than phenol. And the reason, yes, methyl phenoxide ion is less resonance stabilized than phenoxide ion. Here is one of the answer. Or in methyl phenol or cresol, methyl group is electron donating group, and it increase the electron density on oxygen, and OH bond is stronger, or OH bond is said to be less polar, and its ionization is less or poor, and giving lower concentration of hydrogen ion. Hence, the molecule cresol or paramethyl phenol or orthomethyl phenol, they are said to be less acidic, right? Less acidic. Next, among the three paramethyl, metamethyl, orthomethyl, three cresols are known. They are orthomethyl, paramethyl, and metamethyl cresols. Then, among the three is most acidic metamethyl phenol, next paramethyl phenol, last orthomethyl phenol, or metacresol, paracresol, MPO. But in case of nitrophenols, yesterday I told POM, means you have to remember POM, POM. In case of nitrophenol, para-nitrophenol most acidic, but here not para, here meta, right? A metamethyl phenol or metacresol greater than paracresol greater than orthocresol. But all these three less than, means less acidic than phenol, less acidic than phenol. And all nitrophenols maybe ortho, meta, para, they are all more acidic than phenol, then meta, para, and orthocresols. These are cresols. Next, about cresols I told, cresols. Then amino phenol and methoxyphenols, you see, they are extra points. Methoxyphenol and aminophenol, what happened? It may be methoxy or aminophenol. See here. It is called methoxyphenol, orthomethoxyphenol, metamethoxyphenol, paramethoxyphenol. Similarly, orthoaminophenol, meta-aminophenol, para-aminophenol. It may be amine group or methoxy group. If it is present on the ring, yes. And if it is present on the ring at orthopara, yes, these are called less acidic than phenol because this can undergo resonance. Electron pairs, there is a plus R effect. Here also plus R effect. Electron donating group, it is electron donating, therefore less acidic than phenol. Less acidic than phenol. Next, if it is presented meta position, what happens? Meta position. 1, 2, 3. Now here 1, 2, 3. This type you have to give the numbers. Then here plus R. Next plus R absent minus I possible. Minus I effect possible. Here OCS3 yet meta position act as minus I group or EWG group. That's why metamethoxyphenol or meta-aminophenol, they are said to be what more acidic than phenol, whereas orthomethoxy, paramethoxy, they are less acidic than phenol because here there is a presence of plus or effect group. They can undergo resonance. Here also resonance, but here no resonance. Plus or effect here absent, minus I present. That's why it is said to be what EDG group here, sorry, EWG group. It can act as EWG type, hence it is called more acidic. Metamethoxy or meta-aminophenols, they are called more acidic than orthomethoxy and paramethoxyphenols or orthoaminophenol and paraminophenol. So this is about acidic character of phenol based on the inductive effect, resonance effect I explained, and even experiments with sodium and sodium hydroxide. Okay. Now some questions we can expect on acidic character. Explain the acidity of acidity of phenol based on resonance concept, and there you have to write 3 points: ionization of phenol, resonance structures of phenoxide ion, and resonance structures of phenol, and explain in brief about 3-4 lines. Then next question, write the resonance structures of phenol. Then write the resonance structures of phenoxide ion. Why phenol is acidic? Only one line you have to write. Because phenoxide ion is more resonance stabilized than phenol. That you can write. Give a reaction to show that phenol is acidic. Then write the best example using sodium or even NaOH. Phenol reacts with sodium hydroxide to form sodium phenate and water, or phenol reacts with sodium metal liberating hydrogen gas and sodium phenoxide. This type we can write answers in case of acidity of phenol. Then explain effect of methyl group. Effect of methyl group on acidity of phenol, or explain effect of NO2 group on acidity of phenol. So all these questions we can expect in theory paper, and even in CET there is or in objective type questions on acidic character more important. Next we will study some reactions due to OH bond cleavage, then CO bond cleavage. Both we can consider. Reactions due to OH group. Due to OH group. Under this we will study first acetylation or acetylation. Acetylation or acetylation. But this I covered in alcohol topic. So there I told what is meant by acetylation or acetylation. Introduction of acyl group or acetyl group, CS3CO group on the organic group or organic molecule like aromatic ring or open chain. To get acetyl derivative, their process is called acetylation or acetylation. But phenol alcohol amine, and these compounds undergoes acetylation. But alcohol already covered, but next is regarding phenol. Then amine topic already we studied amines. There also studied regarding acetylation or acetylation of amines, maybe primary amine or secondary amine. Okay. Now in acetylation, see here, benzene ring with OH group. This is called phenol. Cl CO CS3 COCl acetyl chloride. Phenol react with acetyl chloride or acetic anhydride, both we can write. But if it is acetyl chloride, then in presence of pyridine catalyst. Yes, in presence of pyridine catalyst, then removal of HCl occurs, H plus Cl minus, this bond shift here, and positive charge goes to negative. Therefore, we get ring O CO CS3 plus HCl. O CO CS3 plus HCl. Yes, we get RCOOR. RCOOR and RCOR compounds are said to be esters. So it is a ester, but name of this methyl, whether benzoate or phenyl acetate. Yes, it is called phenyl acetate. CS3COO is called acetate. Then IUPAC name ethanoate. IUPAC name ethanoate. Therefore, this compound is phenyl ethanoate. But other name acetoxy benzene. Acetoxybenzene, that is phenyl ethanoate. Actually, it is a ester form. Hence, you have to consider name as ester phenyl ethanoate. IUPAC name. Name the product formed when phenol is subjected to acetylation or acylation. Right answer, phenyl ethanoate or phenyl acetate is formed. But phenyl acetate common name, but ethanoate IUPAC name. Ethanoate IUPAC name. Yes, and pyridine application, use of pyridine, so I told in the previous class, there is a pyridine, it is a catalyst having lone pair, and it can combine with HCl, which is formed in the reaction, and electron pair adds to S plus, then we get here, then it is called pyridinium chloride or pyridine hydrochloride. Pyridine hydrochloride. By forming a salt, yes, that HCl can be removed. Therefore, it acts as a catalyst. The catalyst used in acetylation of phenol using acetyl chloride is answer pyridine. Answer pyridine. Next, even we can use a concentrated sulfuric acid. If you take here acetic anhydride, and to cover that one, I will use another example which contains same compound, same group OH. There is a phenolic OH group. And that compound is here salicylic acid. I would use a compound called salicylic acid. Now we will study how to prepare a drug or a medicine that is called aspirin. Preparation of aspirin. Preparation of aspirin. It is a medicine, aspirin, acetyl salicylic acid or 2-acetoxy-benzoic acid. That is IUPAC name of aspirin. It is a colorless, it is a white solid. It is a white solid. And this can act as antipyretic and also analgesic. And so it can be used to lower the body temperature normal during fever, and also it can be used to lower the body pain. It may be any means that is headache or any there is a body pain, maybe hand or leg anywhere. Then that drug, that is a aspirin drug, can be used. But it has some side effects, aspirin. That's why it is avoided. Okay, but it is the best drug that is named as analgesic. It is called analgesic. But now we can explain how to prepare aspirin in the laboratory. Okay. Now by taking salicylic acid, but salicylic acid is a phenolic acid. Salicylic acid is phenolic acid. Now see here, phenolic acid. salicylic acid. IUPAC name carbon 1, carbon 2. Second position OH group 2-hydroxy. This part ring with COH, it is called benzoic acid. 2-hydroxy benzoic acid is called salicylic acid. Now this compound is heated with CS3 COO CS3. It is named as acetic anhydride. It is called acetic anhydride. Next, in presence of concentrated sulfuric acid, can add 2-3 drops of sulfuric acid, or even sodium acetate also can be used, but best is sulfuric acid. Next, see here where the reaction occur. Acetylation occur. It is undergoing acetylation, but acetyl group or acyl group attacks at phenolic OH or alcoholic OH or amine group, but this is carboxylic acid group. Therefore, this compound cannot react with carboxylic acid. It can react with phenolic OH. This H replaced by what? This H replaced by acyl group. Therefore, COO bond break. Then H shift to O. This H shift to O. Then we get CH3COOH acetic acid plus OCOCH3. We get a product OCOCH3 compound. OCOCH3 COOH plus CH3 COOH. This compound is called aspirin. It's a common name, aspirin. But first group, COOH group, here one, position 1, and here there is a carbon oxygen bond, but it is not linked with carbon or COOH. This is COOH, therefore position 1. Now IUPAC name of this one, IUPAC name 2-acetoxy. Second position acetyl group acetoxy. 2-acetoxy, and remaining part is benzoic acid. Therefore IUPAC name 2-acetoxy benzoic acid. 2-acetoxy benzoic acid. Then one more name. This is IUPAC name. Then common name. See here, 1, 2 again. Second position ortho or acetyl. This group is acetyl, and this one salicylic acid. Acetyl salicylic acid or 2-acetoxy benzoic acid. Acetyl salicylic acid, 2-acetoxy benzoic acid, aspirin. So meaning same. But this compound acts as analgesic and antipyretic. Yes, you may get this one in 2-mark question. Give equation for the formation of what? Aspirin. Or explain the preparation of aspirin in the laboratory with equation. This is equation. Yes, how to explain? How to write the answer? Salicylic acid on heating with acetic anhydride. Salicylic acid on heating with acetic anhydride in presence of concentrated sulfuric acid to form aspirin, or to form 2-acetoxy benzoic acid. 2-acetoxy benzoic acid, which can be used as analgesic and antipyretic. Right. So this is regarding how to prepare aspirin or 2-acetoxy benzoic acid from salicylic acid. Okay. And IUPAC name of salicylic acid 2-hydroxy benzoic acid. 2-hydroxy benzoic acid. So this is the first reaction, acetylation. Next we study benzoylation. So difference between acetylation, benzoylation, very simple. In case of benzoylation, we can use benzoyl chloride. Acetylation, acetyl chloride. Therefore, next reaction is benzoylation. But all the reactions important. Practice well. All are important equations. Write 2-3 times reactions. Benzoylation. So we are carrying this reaction in place of alkali, therefore it is also called as Schotten-Baumann reaction. If the benzoylation process carried out in place of alkali, NaOH or KOH, then that process named as what? Schotten-Baumann reaction. That is called Schotten-Baumann reaction. In the absence of NaOH, then simply named as benzoylation. Now see, benzoylation of what? Phenol. C6H5COCl. Benzene ring COCl. This is benzoyl chloride. Plus HOC6S5. In place of benzene ring, I am writing molecular formula C6S5. This is phenol. Yes, phenol on heating with benzyl chloride in presence of NaOH or KOH solution. This is important. Only in presence of NaOH, benzoylation of phenol is said to be what? Schotten-Baumann reaction. They is said to be Schotten-Baumann reaction. Now see here. What happened? Again, this H replaced by H of phenol replaced by benzoyl group. Therefore, the process is called benzoylation. But reaction occurring in place of alkali, then it is named as Schotten-Baumann reaction. And same thing we repeat even in amine topic. Already, firstly, we studied that Schotten-Baumann reaction. There is a benzoylation of aniline, acetylation of aniline. Benzoylation of aniline in place of alkali is called Schotten-Baumann reaction. Okay. Then the product is C6H5COO C6H5 plus HCl and that HCl formed neutralized by what? Alkali in average. Now this is what ester RCOOR. This R group name first phenyl. This is phenyl and remaining part benzoate. The product formed is phenyl benzoate. There is IUPAC name phenyl benzoate. It is ester obtained from phenol and what benzyl product, phenol and benzyl chloride, and in place of alkali, hence it is named as Schotten-Baumann reaction. If alkali not given, it is simply named as benzoylation, right? Benzoylation. Acetylation, preparation of aspirin, then benzoylation. Next, another two reactions, reduction or reaction with zinc dust, and one more oxidation. So in all these reactions, what OH group of phenol is involved. But in another type, there is a electrophilic substitution reaction. Yes, OH group is retained in the product side. Okay. Now first I will cover OH group reactions. Afterwards, benzene ring reactions. Okay. Third one with zinc dust, important reaction with zinc dust and one more oxidation. I don't know zinc dust or alkali metals or even alkaline earth metals. aluminum, even zinc. These elements are metals, they are said to be a good reducing agents because they have negative SRP values. They have negative SRP value or lower SRP values. If SRP value less or negative SRP values, then it is said to be what a good reducing agent. Therefore, zinc acts as a reducing agent. It can reduce phenol to zinc, phenol to benzene. Means from phenol, oxygen is removed by zinc metal. If oxygen is removed, then the process is said to be what? Reduction. Removal of oxygen, reduction. Addition of hydrogen, also reduction. But here, O is removed from phenol by using what? By using zinc dust. Phenol plus zinc. This is dry distilled. Without adding water, just add zinc powder and heat with phenol. After a few minutes, yes, we get a colorless liquid, and that liquid is plus ZnO. Means during the reaction, see what happened. Because of zinc here, it can cause a radical formation, and O with 2 electrons, zinc adds to with O, ZnO, but it loses 2 electron, 2 electron plus 2H plus, or 2 electron from the hydrogen, and they can form what? Or this H goes to what? ZnO plus H goes to bring, then we get a compound benzene. So consider there is a H here, it is a benzene. It is said to be benzene. Conversion of phenol to benzene. Next, what happens when phenol is distilled with zinc dust? There is a question. What happens when phenol is distilled with zinc dust? Yes, answer is what? Benzene. Give equation for the reaction of phenol with zinc dust. Write this equation, that carry 1 mark. But explain conversion of phenol to benzene with equation. Yes, definition, and this equation would write, that carry 2 marks. Okay. Now see the application of such reactions. What is the use of zinc dust in organic reactions? I will give you different molecules, and using zinc dust, see what happen in Now you take example OH, COOH, OH, COOH, zinc dust, ring OH, CO, CS3, ring OH, CS3, cresol, this one, 2 hydroxy acetophenol, 2 hydroxy acetophenol, or acetyl phenol, but we cannot say like that. It is a means having higher priority. Then it is said to be what? Keto acidic compound. Then, so when it is heated with zinc dust, see what happens. In all the 3 cases, zinc dust. So function of zinc in organic reactions, it can remove phenolic OH group, and this H goes to the ring. Therefore, we get yes, only phenolic OH disappear. Therefore, this is said to be what? Acetophenone is formed. Acetophenone. Only this group disappear. Next, same type. So remove this OH group. Now we get only benzoic acid. This compound is benzoic acid. Next, last, zinc with say cresol. It can form. Yes, toluene. Cresol to toluene occur by using zinc dust. So this shows in organic reactions. Yes, if you take a phenolic compound, any phenolic compound, heat with zinc dust, phenolic OH group disappear, or that undergo reduction, yes, by using zinc dust. Okay. Next, one more reaction that is called oxidation reaction. Oxidation. First, acidic nature. Second, acetylation. Third, benzoylation. Fourth, reduction. And this is fifth. Fifth reaction, oxidation. Yes, process of addition of oxygen or process of removal of hydrogen. If H is removed or oxygen added, then the process is said to be oxidation. But here we will take a phenol example. Phenol exposed to air and light, it can convert into a red compound or colored compound that is called para-benzoquinone or para-phenoquinone. Quinones are obtained. They have what color? Means any maybe reddish or pink color is obtained. But if you take oxidizing agent such as sodium dichromate in sulfuric acid, acidified sodium dichromate, acidified potassium dichromate, or even constant nitric acid, KMNO4, yes, they are said to be very good oxidizing agents and they liberate during the reaction. When these two combine, they produce atomic oxygen and nascent oxygen, and this nascent oxygen is very active and it can oxidize what? Phenol into quinones. Means para position H equal to OH, ortho H equal to OH means orthoquinone, para quinone, di what? Ketones, aromatic, there is a aromatic compound changed into diketone or conjugated diketone is obtained. Yes, this is said to be conjugate diketone and is called para-benzoquinone or para-phenoquinone or para-phenoquinone. Actually, this undergoes what? Oxidation at para position, and here we get OH, and because of O, this can remove H, converts into water. Two H and O, S2O, and this undergoes a resonance. Let it be here. Next, like this you can write resonance structures. Then the position of double bond changes. Again undergo resonance with this O, and finally we get what? Diketone. It is said to be conjugated diketone. Why it is called conjugated? Double bond, single bond, double bond, single bond, double bond. Again here single bond, double bond, single bond, double bond. If double bonds in alternate position, then it is said to be conjugated system. Then it is a conjugated diketone, and such compounds are called quinones. These are at 1,4 position. It is para-phenoquinone, para-benzoquinone, or 1,4 quinone. Then if it is present at 1,2, it is called benzoquinone, orthobenzoquinone, para-benzoquinone. But major product, this one, para-benzoquinone. So these are some of the important reaction, but you may get this one in exam. Left side given in the question paper and fill in the blank. Means you write this what structure. Then other type question, explain oxidation of phenol with equation. This write this equation and explain in brief by using oxidizing agent such as acidified potassium dichromate or sodium dichromate. They oxidize phenol into para-benzoquinone or para-phenoquinone. So these are the reactions under what? The reactions under reactions due to hydroxyl group, OH group on the benzene ring, OH group on benzene ring. So next type of reactions due to what? Benzene ring. That is called electrophilic substitution reactions. Electrophilic substitution reactions of phenol. Then we can study two reactions. There is a named reaction, very important. They are called Kolbe's reaction and Riemer-Tiemann reaction. Kolbe's reaction and Riemer-Tiemann reaction. Reaction due to benzene ring. Reaction due to benzene ring. There is nitration, sulfur, etc. that we can study in next video. Okay, thank you.